2, 1, go. All right.
We have seen that any number a raised to the nth power, where n is a positive integer, is equivalent to n a's multiplied together. Interesting things happen when we multiply exponential expressions together. For example, say that we multiply 4 squared times 4 cubed. Since 4 squared is 4 times 4, and 4 cubed is 4 times 4 times 4, the result is 5 4's multiplied together, which is equivalent to 4 to the 5th power.
Okay, so in our laws of exponents, we're talking about multiplying with a common base. Anybody, what is the common base here? 4. So in this example, and I know the play sign is in the middle, but it's 4 squared times 4 to the 3rd. So the result is that you have 4 to the, anybody? 4, no, you're looking at this already. You're working ahead. Look at on the screen. 4 to the, so to sum up, when multiplying powers with a common base, what word works here? How about, we don't know, we don't add the base. We don't multiply the base. The 4, did the 4 change? No. So we carry over. How about just keep the base and what do we do with the exponents? What did we add them? We add the exponents. So 4 squared times 4 to the cubed is 4 to the 5th power. So we can do these examples. 4 to the 4th power times 4 to the 3rd power then is 4 to the, now Jenna, 7th power, right? So if y'all can work those examples out quickly, see what you get, and we'll just check in about 30 seconds. I was just kidding. It was about 10 seconds. How about 9 to the what? 6. You don't need to find the number. All we're doing is adding simple exponents. This is a to the 7th. This is x to the 7th. Okay, so this rule is called multiplying with a common base. Okay, it prevents you from having to use a calculator, right, and multiply all that out and then multiply it times all this. It just helps make things easier. Okay, rule number 2. Okay, rule number 2. Now y'all can't see the video. Okay, so there's this 5 to the 3rd times 5 to the 4th. Let's try to find a, okay, so rule number 2, you can,
After canceling, we are left with 3 5's multiplied together. So 5 to the 7th power divided by 5 to the 4th power is 5 to the 3rd power.
Okay, so in this case, when you're dividing powers with a common base, you keep the base and subtract. Okay, so let me rephrase that real quick. When we multiply the bases, what the exponents? Add the. What is the opposite or reciprocal of multiply? Division. So what is the opposite of addition? So it makes sense if we multiply the bases, we add the exponents. So when we divide the bases, we subtract the exponents. Okay. Now, so I'm going to do this one in longhand. Pausing the video. So dividing the powers with a common base, you keep the base and subtract. So we're talking about dividing. So I'm going to blow this one up into an expanded form just to make it more amplified, but you don't have to do that with these others. 9 to the fourth is 9 times 9 times 9 times 9. Yes? This is 9 to the third, 9 times 9 times 9. Now, what is 9 over 9? Is 1, right? So these, in effect, cancel out. What's left is this, is 9. Okay? So this is 1x, yes? So this ends up being x to the second power. Okay? Now, we've talked about cowboy and the horse before. What do you say first, cowboy or horse? So this is the cowboy and this is the horse. Draw a little asterisk. Always, spell always correctly. Always subtract the denominator from the numerator. Now, that you're probably like, duh, but here's the thing. If your exponent in your denominator is larger than your numerator, you're going to have a negative exponent, and that's what we're going to. All right, so moving along. So this leaves us with 5 to the what power? Fourth power. Y to the 8 over y to the third gives us y to the fifth power. Fifth power. Okay, moving along. Okay, we've got a good example here. So
note two exponential terms are constant subtracting exponents. And when we divide exponents with the same base, we subtract their exponents. We get a with, so we sequence to two copies of a.
Okay, here's a good
together, which is a times a times a times a times a times a.
Okay, so Christian, stop it. Okay, so here we have the third rule. It's the power rule. So basically you have a power raised to a power. You have a power raised to a power. So the power raised to the power is, guess what we're going to do with the base? Keep the base and check this out. So if you have,
of course, 6 a's multiplied together is a to the 6th power.
So what just happened with the power and the power? They were multiplied. They were multiplied. So we'll multiply the exponents. So this is this is why it's called the power rule. So 4 to the fourth to the third power is 4 to the what? 4 to the 12th, right? 9 to the fifth to the second power is 9 to the 10th. Okay? A to the fourth to the sixth power is a to the... No. No. See, that's the thing. That's where you're getting confused. You're not squaring it. You're literally multiplying the exponents. Okay, so here's the thing, and this leads us to our next rule, and I promise after we cover the next rule, I'll turn you loose. X to the second power raised to 0 is 1. That leads us to the fourth rule, which is, look, this is important. Any number raised to the power of 0 is always 1. Any number raised to the power of 0 is always 1. Okay, for the fifth and final rule, it's for negative exponents. It's how to think about negative exponents. So when the exponent is negative, you flip the fraction and get rid of the negative sign. So this is a reciprocal. Okay. So she starts with some kind of tough examples. And what I want to do real quick is just, let me start with this one. So x over negative 6. So what's the opposite when we did KFC and we were dividing fractions? We'd say write the whole number as a fraction. So we'd say x over 1, right? So the reciprocal of that is 1 over x. Yes, we flip it. So in this case, x to the negative 6 is equal to 1 over x to the 6. So we flip it and we make it whole. So it ends up being like this: 1 over x times x times x times x times x times x. So it makes a really small number. So a negative exponent is about making something really small. Okay? All right, let me try to do a couple more examples with you. Okay, so this is 1 over, okay, so this is a to the third times b to the negative 2, right? So we'd have a to the third power times 1 over b to the second power. I'm gonna end just by saying this. So like these examples are way out there, more complex than anything we're going to do this year. If you can simply say that 5 to the negative 3 is equal to 1 over 5 to the third, or 1 over 5 times 5 times 5, that's, if you can do that, that's good enough.